Here's another important part under this concept of counting principles. Let's say we are given WXX, then they ask us how many arrangements can be formed out of these three alphabets of the password that we can form. We have three of them, right? So we have three alphabets here. So how many ways we can actually make three passwords? This can be one of the ways, and okay, let's just say XWX. XWX, we have XXW, and the very same one that actually given us, because we can use it as our password or one of the arrangements that we can use. So how many arrangements can we form out of these? Maybe three, because I don't think we can form another arrangement using these three apart from these three. So how many arrangements do we have? These are known as arrangements. So we have what? Three arrangements. I hope it makes sense. So all of these are known as arrangements that we can possibly form out of these three alphabets, WXX. Okay, then remember it's WXX. What we have now is that we have three alphabets. Now they ask us how many arrangements can we make. So 3 factorial. 3 factorial, it means that we can use what? Repetition is not allowed. Therefore this is what we have 6 arrangements. We only use this format if there's a restriction that they said that we can use these alphabets as different alphabets or letters. Then we won't regard X and X as one alphabet or same alphabet. I hope it makes sense. I hope that makes sense. We'll do it like this if they said in the restriction that we must treat these two alphabets as if they are different letters. But I'll also show you if they don't say treat them as different letters or use them as same letters, what do you do? But you do this one if they say treat them as different letters. I hope it makes sense. So that 6 and the 3 doesn't make they don't correspond actually, because we have 6 arrangements and we have 3 arrangements. Let me actually show you what happens. Now we have WXX. Now here we're actually forming the arrangements. Then the restriction, they told us that we must actually take them, or we took them as different letters said by the restriction. But if they don't say this, it means that you must take them as same letters or same alphabets. I hope that makes sense. So if we took them as different letters, we write 3 factorial, and repetition is not allowed. So this one, it will be 3 factorial. Why? Because we see how many 2 alphabets that are the same. Then this division sign means that there are 2 alphabets that are the same. Then it will be 2 factorial. Then the answer is going to be 3 times 2 times 1 over 2 times 1. Then 2 and 2 will cancel, and 1 and 1 will cancel. I hope it makes sense. Then we have how many? We have 3. It matches with the number of arrangements that we actually found here. But you only do this one if they say that take them as what? As different letters. But if they say take them as if they don't say take them as different letters, it means that you must take them as same letters. This is what you do: 3 factorial over 2 factorial.